All right, can you guys see this? Parsha, I only see you now. So give me a yay. Or I can see Linda too now. All right, so this guy, really famous guy, you guys. Not just in the West, also in the East. World famous and the favorite of the church. His name is Claudius Ptolemy. Born 100 AD. So it was maybe 98, 97. Somebody just rounded it off to 100 AD. Now, most of these people were librarians at the Library of Alexandria. Remember, we talked about the Library of Alexandria last time. Now, so most of these Greeks, they spend their time at libraries. That's what the libraries were for. They were learned people. And so that's why that 1 million library books were there for them to use. The only bad thing about the Greeks was the fact that they had slaves. And because they had slaves, they destroyed themselves, basically, right? Eventually, the library is going to get burnt down. The slaves are going to burn it down. When I was in Egypt, there was only a door left of the library. Everything else was burnt down. So they can tell you where the library used to be, but it's not there anymore in Alexandria, which is a beautiful city. Also, that was one of the wonders of the world was also there. That big giant lighthouse of Alexandria was there. Well, there was this giant statue in the sea that showed all the sailors, where Alexandria was. That's also gone, but there's a base of it is still in the Mediterranean Sea. So now this Ptolemy is famous for two things. One is his theory of geocentric, which means Earth-centered astronomy or astrology back then, the way it was called. And by the way, by this time, 100 AD, the Romans had already taken over. So after the Greeks, Roman Empire comes next. So Greek Empire, then Roman Empire. That's how the Western civilization is going to proceed. So this Roman, Claudius Ptolemy, his name is definitely Greek. He was really into the theory of astrology and astronomy. And his theory is going to be one of the longest theories in the history of man. Even though it was wrong, it's all right, had a wrong theory. But it worked. Using his theory, people were able to predict eclipses. They could tell, like, in 2 years, there's going to be an eclipse and what have you. So this Claudius Ptolemy, he writes a book. In his book, he doesn't just talk about astronomy, he talks about all kinds of stuff, right? And one of the things that he talks about is the theory of the Earth being the center of the universe, called the geocentric theory. Now, I put it side by side with the heliocentric theory. Helio is also a Greek word name. It's the sun. Helio is the sun. Geo means Earth. So in the Earth center theory, the geocentric theory, the Earth is the center of the entire universe. In the sun center theory, the heliocentric theory, the sun is the center of the entire universe. Now, here, this theory is going to get modified and modified by Ptolemy. And he has the moon, the planets, the sun, everybody going around the Earth, the entire universe going around the Earth. And they didn't call it a solar system or local solar system, the local universe. They call it the universe. They had no idea how big the universe was. In fact, until 1920s, we didn't know how big the universe was. We thought the universe was our galaxy. That's it. And then we found out there's other galaxies out there, and our universe became so much bigger. The universe used to be about 100,000 light years in diameter. Now it's almost infinite, probably 96 billion light years in diameter. So now it says firmament out here. Does anybody know what firmament is? Firmament, you must have read in the Bible if you read the Bible. Firmament is the heaven, right? That's where God lives. God lives in the heaven. And these are spheres, by the way. They're not just planets going around. They're going around on a sphere. So let me show you this sphere. So there's the Earth in the center. There's a sphere of the moon, sphere of Mercury, sphere of Venus, sphere of the sun, sphere of Mars, sphere of Jupiter, sphere of Saturn, and then there is the stars. That's my favorite part, is the stars. Because what the stars are, according to the ancients, they're the prick holes, basically holes in the floor of heaven. So where God lives, there's holes in the floor. I guess, they couldn't fix the floor perfectly or something. And so the light of God, the one that Moses saw and Moses heard turn white and all that, well, the light of God goes through the holes in the floor of heaven, and that's what he said the stars are. So that's a theory of what the stars are according to the ancients. They couldn't figure out what those little lights are. So that's their theory. It's God's light coming through the holes. Now, as this theory is modified, it was very useful. It actually worked. And it became a favorite of the church, of the Catholic Church, because the Catholic Church at one time, like 1,000 years ago, it was the center of the world, center of the earth. So imagine, maybe the Pope is the center of the Catholic Church. Catholic Church is the center of the world, the earth. And then the earth is the center of the universe. That makes the Pope the center of the universe. That's pretty impressive, to be the center of the universe, not just the center of the earth even. And so the church defended this theory until very recently. We're talking about the last couple of hundred years, basically, right? Even Galileo got a lot of slack, and this is only like 400 years ago, and Galileo was publishing his books and arguing with the people in the church. Now, he published a book called Almagest. Almagest is an Arabic name. We don't have the original Greek book that Ptolemy wrote. So Almagest means the majestic. This is the majestic. Imagine a book that somebody calls the majestic. He didn't call it the majestic. Ptolemy didn't call it the majestic. The Arabs called it the majestic because it was translated from Greece to Arabic. And this is a time of the Byzantines. And then what happened was eventually it was translated to all the other languages. In fact, this book has been translated more than any other book in the history of man, probably. So this guy here, right, this guy here translated from Arabic into English. It's a pretty impressive book. They still sell it. You can buy it on Amazon. We have it in the library and so on. In it, there's pictures. In it, this is the actual copy of the book. And you can see a lot of diagrams. He's got a lot of circles. To him, circles are everything. He's got circles within circles within circles. But then he's going to run into some problems too. One of the problems he's running into was the fact that one of these planets, Mars, was not behaving. It was not doing what it's supposed to be doing. So what was Mars doing? Well, Mars appeared to be going backwards in the sky. So now imagine you're looking at the stars here. All right, so here's a part of the sky, stars. So as you're watching the stars, Mars, in fact, this is awfully close to the color of Mars, is sitting here. Tomorrow night, Mars is over here. That's why they call them planets. It means wanderer. So Mars is wandering amongst the background of the stars. So the stars are in the background, Mars is in the foreground. And as compared to the position of the stars, Mars's position is changing. So tomorrow night is over here, then over here, then over here, then over here, then over here, over here. And then it starts going backwards. And then starts going forwards again. Now that's very curious. And he couldn't figure that out. Why is Mars doing that? Well, it turns out the reason Mars is doing that is the following. We know now what Mars was doing. He didn't quite understand it back then. So he has a different solution. I'll give you the actual solution here. Then I'll give you the solution that Ptolemy came up with. In our solution, I'll explain to you guys what happened when my grandma was driving in the freeway at 50 miles an hour in the left lane while she was drinking coffee. All right. So as she was drinking coffee in the left lane, I passed her at about 75 miles an hour. Then when I saw my grandma in the mirror, she appeared to go backwards. Even though she was traveling forwards in the freeway, she appeared to go backwards to me because she was going slower than me. So as you drive in the freeway, hopefully not for a long time. Stay away out of the freeway right now. But if you are in the freeway, you pass somebody, look at them in the mirror, they appear to go backwards. They don't appear like they're going forwards. When you approach them, they appear to go forwards. When you reach them, sometimes you can look and see somebody in their car. Like if you're in a car, I look around and I see you guys doing whatever. Maybe they're texting or something. You can see them if you're going the same speed anyways. And then when you pass them, it appears they're going backwards. And that's what's happening here. So as the Earth goes around the sun, it goes much faster than Mars. Mars takes approximately 2 years to go around the sun. The Earth takes about 1 year to go around the sun. So from the Earth, you look at Mars, and Mars appears to be over here. And then Mars, as we approach it, appears to be stationary, and then it starts going the other way as you pass it. So this is the same as me reaching my grandmother, and then I can see my grandma is drinking cigarettes, drinking coffee and smoking cigarettes. And then my grandma did smoke cigarettes. And then when I pass, she appears to go backwards. That's the real reason why Mars was going backwards. Now, what did Ptolemy say? Oh, Ptolemy's idea was this. Ptolemy said that Mars was in a special circle called an epicycle. Epicycle spelled E-P-I. E-P-I, cycle, epicycle. So because it's on an epicycle, he says from the Earth, you look at Mars. When it's going in this epicycle over here, you see him going one way. When it comes back around, appears to go the other way. So this explained the backwards motion of Mars, called a retrograde of Mars, for the ancients. This explained it. And then soon, it appeared that the Earth had some sort of problems because the exact formulas weren't working very well. It was a little calculation, miscalculations. So he also took the Earth from the very, very center and moved them out to the side a little bit, put the Earth on its own epicycle. So he's tweaking it. This to me is called the fudge factor. Do you guys know what a fudge factor is? I bet you Mina knows what a fudge factor is. Do you know what a fudge factor is, Mina?
No.
No? Well, you probably have done this yourself. I've done it when I was going to school. It's like you look in the back of the book and you get the answer to a question, and then you go solve the question so you can get that answer. That's called fudging it. Of course, remember what color fudge is, so you can figure out what that means, fudging it. It means sheeshing it, basically, right? And so he knew the answer. He knew what was happening. So he fixed the Earth so he can get the right answer. He moved the Earth to the side a little bit so he can get the correct answer for his calculations. That's a fudge factor. Now, the Catholic Church is going to love this theory. This is the longest lasting theory in the history of man because, like I told you, it made the Catholic Church very, very happy. A lot of people are going to die because of this. If you argue with the church that this is not a true theory, you will be put to death. They put a stick in the middle of some kind of a square, and they burn you alive. Alive, I tell you. So the smell must have been horrendous. Yeah, those are the dark ages. All right, so that's the story of this Mr. Ptolemy and his retrograde motion of Mars and his book, Al Majest, the Majestic. There's more in it. It's a definite reading book. You can figure out what the science of the time was all about. But I'll tell you one thing. In fact, I want to do you guys a favor and show you something that you probably have never seen. And this has to do with the Greeks in general. The Greeks had slaves, lots of slaves, right? They were rich. You know, they conquered the world. They were the epicenter of the world themselves. And so they didn't think that they had to really do any experimentation. They just used their brain because they're so smart. All they had to do was to sit someplace and meditate, and the information in the universe were somehow coming to them instead of them going out and doing investigations. All right, that's wonderful. So for 2,000 years, 2,500 years, these Greeks had their golden age, and they were fantastic scientists and all that, but they never actually did any actual observation, right? Let's see if I can find these balls here. So I have two balls for you. There's a ball, and it's about 3 ounces. And here I have something I just got. You guys recognize this guy. This guy is not even 1/10 of an ounce. Very, very light. I'm going to drop these two at the same height. See what happens. Let me just change cameras. All right. There's my floor. Okay, let's see now. I'm going to drop these, you guys. Watch it. When they hit the floor, you expect this one that is heavier to reach the ground first. And yet they both reach the ground at the same time. But maybe that was just an error. Maybe let's do it again. Let's see what happens. Oh, no. It's true. They both reach at the same time. Amazing. At the same time. And it doesn't matter if you have a boulder, if you have a little tiny feather, they should all reach the ground at the same time. We do this experiment in the physics department, and what happens is that if you have the feather and a bowling ball in vacuum, where there's no air resistance coming down, they both fall at the same time. The astronauts did the same experiment on the moon. But the Greeks never did this, ever. They thought that because a rock is heavier and much bigger, that should reach the ground first. Because they were sitting down thinking about it. They weren't actually doing it, right? So now you can kind of get a appreciation of what the Greeks were really like, right? So now this brings us to Mr. Copernicus. Things are going to change now. Copernicus is going to come into the 15th century. He's born in 1473 and is going to die in 1543. Galileo is going to be born when he dies, when Copernicus dies. And when Galileo dies, Newton is born. It's like the same guy being reincarnated 3 times. Most amazing thing, right? These guys worked exactly on the same problem. Now, let me ask you something. Do you guys have intuition? They say women have intuition. I don't believe that. I think everybody has intuition. So let me ask. Let me see what you guys think. Before my mom called, she's passed away now, but before she passed away, I knew 5 minutes before she called that she's going to call. That's intuition. I don't have any idea where it comes from. Does anybody else have intuition like that? Like you know something's going to happen before it happens? Seriously?
All the time, yeah.
All the time.
Yep.
Okay.
That's me with my mom too.
Yeah, I have no idea what that is, but it's the truth. Right?
I think it's a product of our brains finding or trying to find patterns.
So you think my mom is gonna call in 5 minutes? There's a pattern there, like she
maybe not one.
6
Maybe
months
not
ago?
one you can see, but maybe there is.
Yeah, well, I think you said it at first. You said I think.
Yeah.
If you think, then that doesn't work because intuition had nothing to do with thinking. That's the whole point. Intuition comes from your guts, right? Now, when you say it comes from the guts, right? What does that mean? It comes from the guts. What's in the gut, right? Does anybody know what's in the gut?
You say it's like a gut feeling, like when you feel it.
Yeah, well, the gut feeling comes from the solar plexus. The solar plexus are just above your navel, and that's what they call the gut. So solar plexus is a center of intuition in Chinese acupuncture too. You know, it's like if you have your meridians in your body and all that. So there's got to be more to it. I certainly believe that there's more than just your brain inside of you. There's more to it. Regardless, he's going to go, oh, there you go. Maternal intuition, right? Like something bad happened to my daughter or my son, I would know ahead of time. It's an amazing thing. So guess what? Copernicus, and by the way, Copernicus spells Copernicus. This is Copernicus written as Polish. He was Polish. So this is Nicholas Copernicus in Polish. He was a priest. He wasn't a scientist, he was a priest. But back then, most of the priests actually did science. Like they went to the fields They picked up some flowers. They picked up some vegetation. They tried it out. They boiled them. They gave it to people that were sick. And, so they did doctoring too. They did, observations. They did all kinds of stuff. And so he was kind of like that. He was like a scientist, priest. He was definitely not against the church. He respected the church immensely. But then he had this idea that the sun is the center of the universe. So the sun in Latin is written as Sol, S-O-L is the sun. So he puts the sun in the center of the solar system, and then he has all the planets and everything going around the sun, not the earth. He put the moon around the earth, orbiting the earth. There's Terra, there's the earth. So everybody is going around the sun. This is called a heliocentric universe, the earth-centered, the sun-centered universe, I'm sorry. And he wrote a book. I put the translation down here. It's Revolutions of Heavenly Bodies. So the revolution of heavenly bodies discusses the sun-centered universe. When he wrote a book, he couldn't actually publish it locally. He had to publish it somewhere where nobody else would know about it and be kind of private. Where do you think there's the only place in Europe that you could publish something 500 years ago? Can you imagine where that would be? If I give you a clue, you would all know.
Rome?
Rome? No. Somebody said England. I go, oh yeah, England. No,
Greece.
let me give you a clue. In this place, 50 years ago, you could smoke marijuana outside in a cafe.
Amsterdam.
There you go, Amsterdam. See, I told you. Give you a clue, and everybody knows now. Amsterdam. But he didn't go himself. He sent his student to go to Amsterdam, publish the book. Now, the printing press, it's not even invented yet. So they had to write this by hand. So they published by hand, like that. So the student publishes it, brings it back to Copernicus. Copernicus has fallen ill. He's on a bed laying down. And as soon as he brings it in, puts it on his belly, puts it down, right then Copernicus dies. Right then, as soon as he sees the book, he dies. It's like he's waiting for the book to die. He sees the book, and then he dies. Now, this book is in the library. It's expensive and it's beautiful. It's a beautiful, beautiful book. Everybody who was anybody got a copy of this expensive book, including Galileo, Kepler, Tycho Brahe, everybody that was somebody famous that we know of in physics or astronomy had this copy of this book. There couldn't be any more than maybe 12 copies published originally. All right, this is actual copies of the manuscript. You can see it. Okay, so now Copernicus dies, and he doesn't have to fight with the church over this. It's finito. But right after he dies, he's born again in the body of Master Galileo. I don't know. It's a good story if you believe in reincarnation, I guess. Master Galileo is the father of experimental physics. And he was born in 1564. And when he's born, the world was changing, sort of. And he's actually handsome. Take a look. He's not look. Most of the time you see his picture like that, right? Well, this is 80-year-old, 80-year-old Galileo, 78-year-old Galileo. This is Galileo in his 20s. So he's kind of a handsome man. Galileo was also going to be a priest. His father wanted him badly to be a priest. Galileo wanted to study math. And so they sent him to his uncle in Pisa. And so he went to school and he studied math and he started teaching in a school. He wanted to get a better job. He wanted to work in a better university. So he needed some kind of a gimmick. And that gimmick was given to him when the telescope was invented. Now, who invented the telescope? If you read the book, they'll give you one name. If you ask me, Telescope was invented by a kid, perhaps 13 years old, working in his dad's glass shop. Back then, 400 years ago, people were not using eyeglasses like this. They had monocles, which was just a lens with a string attached. And they put the lens in their eyes like this, and they hold it in with their eye socket, like right here. They hold it in like that. You've seen it in the old movies, the classics of 1920s and 30s. So now, if you put two of these lenses together, that's what a telescope is. Telescope is two lenses, and the only difference is something we call the focal length. Focal length is like when you put the lens in the sun, you can burn a sheet of paper, like you get a lens, you burn a sheet of paper like this. And the distance between the lens and when the sheet of paper is burning, that's called a focal length. If you have two different focal lengths, the longer one goes in the front, the shorter one goes in the back, that's a telescope. So as the story goes, this 13-year-old boy was working in his dad's shop. One story says there were nuns across the street. So he looked at the nuns across the street while he was playing around, and he saw the nuns a little closer. Another story says that they were not nuns. There were these girls across the street, and he was checking out the girls. Whichever story is true, I think it's a much better story than talking about Hipparchy, inventing telescopes. This is the guy that gets the patent for it. That's a way different than somebody that actually first invents the telescope, right? So the Dutch government is still making money off these patents, believe it or not. Unbelievable story. So let's get back to Mr. Galileo. Now, Mr. Galileo gets himself one of these telescopes. Initially, it was only a 3-power telescope. Even with this 3-power telescope, he could look into the ocean and see things much closer. So he could go to the market and say, hey, man, if I look and see a ship coming in, let's say I see a flag of Valencia, would that be worth some money to you? And the merchants would say, of course, we can put our oranges on sale. And then when a new shipment comes in, we can sell it at a good price. So, okay. So he did that for a while. He probably made enough money to buy a house and everything too. We call that insider trading these days. You can't do that. That's against the law, right? So like if you know the price of Tesla is going to go up tomorrow and somebody tells you ahead of time, you go to jail. My cousin went to jail. He had insider trading. He went to jail for 2 years for insider trading. So Galileo was doing some insider trading. He built himself a telescope, and he used to take this telescope around and show it to different people. That got him a job eventually. So he got a much better job at a better university. And he had a friend that they used to do observing in his backyard together. The second telescope that he built is the one on the left here, this one here. This is the second telescope. This is like a finder telescope, so you can find stuff. This is so you can look at stuff. So as he looked at this stuff, this is the actual telescope. He could magnify about 8 times. That's it. With his 8-power telescope, he looked at the moon and the stars for the very first time. And this is what he discovered. So his discoveries are important because he's going to change the world. First thing that he discovers is the moon. He looks at the moon and he sees the moon has craters, giant craters. And it's got some mountains. And it's got some dark areas they're called seas, like Mediterranean Sea, At least that's what they thought. And the white stuff on the seas, they thought they were clouds. So he made these drawings, and pretty soon he started observing other stuff. He pointed his telescope towards the Milky Way. And the Milky Way, this is from his manuscript, from his book, The Starry Messenger. In The Starry Messenger, he talks about the stars appearing to be what makes up the Milky Way. So he said the Milky Way looks like a pasture land of stars. In other words, there were like little grass that shows up all over the place. Little stars show up all over the place when you look at the Milky Way with a telescope. So he solved the mystery of the Milky Way. Milky Way is made of stars. Right? I wonder if it's his handwriting too. All right. Next, and this is very dangerous, so please don't try this at home. Next, this is his original drawing. He looked at the sun, but you don't look at the sun directly. He projected the image of the sun. He put a sheet of paper behind the telescope, so the image of the sun was projected, and he saw some dark spots on there. He called these the sunspots. So he discovered the sunspots, and he also noticed that the sunspots are moving. So he discovered the rotation of the sun. So the sun is rotating approximately once every 28 days at the equator of the sun. As you go higher up, they go slower and slower. So it's not the best way to measure the rotation rate of the sun. If you go up here, these guys probably go once every 29 days, 28 days. Way up here, probably once every 31 or 32 days. So its rate of rotation is very strange. So he discovered the sunspots and rotation of the sun. And then he made the big discovery. He discovered, and again, this is his handwriting, is his notes, right? I'll magnify it for you so you can see his handwriting is pretty impressively handsome. He's got Jupiter. You can't see Jupiter because his telescope was only magnifying 8 times. So it's a very bright object and he couldn't really tell what it is. So he kind of makes it into a very bright star here. Then he's got little tiny stars orbiting it. These are the moons of Jupiter, and their position was continuously changing. So it was like on one side of Jupiter here, one on the other side. You can see all the moons are moving around Jupiter. Now, if the Earth is the center of the universe, why are the moons of Jupiter orbiting Jupiter? So he discovers the 4 moons of Jupiter are orbiting Jupiter. Big one. But I think his biggest discovery is as follows. It's the crescent and phase shifts of Venus. He looks at Venus. It is also very bright. He sees crescents like the moon. He sees like a half a Venus, like a quarter Venus. He sees a full Venus. But note, when the Earth is closer to the orbit of Venus, the crescents are much bigger than when the Venus gets farther away because it's orbiting the sun. So here it's much smaller, more difficult to see. Now I'm going to put this side by side so you can see what the deal is here. The deal is that this is a proof that the sun is the center of the entire solar system, universe, as he says it. Now, if this is the center of the epicycle of Venus, because Venus also shows retrograde motion, backwards motion. If this is the center of the epicycle of Venus, remember, epicycle is a tiny little cycle where around this circle, the planet orbits like Mars, goes around like this. So as it goes around the sun, it also does this, right? I'm sorry, as it goes around the Earth center. So this is the center of the epicycle. The sun is on the outside. And if this is the case, Venus should always show a crescent. That's not the case. Only if the sun is the center instead of the epicenter being the center of Venus's orbit, where you have crescents and full Venus and shape of the crescent change and all that. And so this is the proof that the sun is the center of the solar system. So he changes the universe basically. So what happens now? Well, he shows all this to his best friend. I don't know if his best friend, but one of his good friends. So his good friend is the Catholic Church. It's not the Pope, it's a cardinal. Now, cardinals like second best in the church. You know, first there's the Pope, then the cardinals. They're the ones that choose the new Pope. So he shows all this stuff to his friend in his backyard and everything. Goes, look at this, look at this. He sees the moon, he sees everything. And he goes to Vatican. And at this time, the Pope dies. When the Pope dies, they have to choose a new Pope. And you can guess who becomes the new Pope. His friend becomes the new Pope. And his friend takes him around at the Vatican and says, come look at stuff here. And intentionally, he takes him to hear. He doesn't want to show him. He wants to hear people being tortured. They had torture chambers at the Vatican back then, 400 some years ago. So when Galileo hears the torture, he stops talking about the sun-centered universe stuff. He changes his tune, right? He changes his tune, and then he starts publishing more books. In Amsterdam, he sends his son to publish more books. So as he's publishing more books, the church gets a hold of one of these books. And in one of these books, he makes fun of a priest in the book. And the Pope thinks that that priest is him. It probably was him. And he makes the Pope look like a total idiot. His conversations with a priest, basically. That's the whole book is about. So he talks to this priest about the sun-centered universe, the heliocentric universe. And it makes him look like a monkey. And so the Pope doesn't appreciate this. And so what happens next is history. What happens next is Inquisition. They take him to Vatican, and he has to answer some questions. Now, he denies everything anyways. He denies everything. And as they say something like, the Earth is flat and the entire universe is orbiting the Earth, Galileo is famous that said, under his voice, he said, and yet it rotates. So he tells them that the Earth doesn't rotate and nothing, the Earth is not going around the sun or nothing. And then under his voice, he says, and yet it rotates. They send them home. They say, you're under house arrest. And Galileo at this time is blind. He's blind under house arrest. And he writes another book and he sends it to get published. And then he dies. That's the story of Galileo. But Galileo is not just famous for looking at the moon and the Milky Way and the sun and Jupiter and Venus. He's also famous for doing experiments in physics. He's considered the father of experimental physics. This is called the law of inertia. Law of inertia that says that basically this is what it says. The Greeks used to think that everything that is stationary is in a natural position. I don't know, can you see my cell phone stationary in my hand? Like that's the natural position of, this is the natural position, stationary, right? Natural position of my telephone. You see the telescope behind me over there? That's a natural position of that telescope. Well, it turns out that Galileo says the natural position is motion, that everything is moving. And in fact, you have to put an extra force to stop that motion. Now, this did not go well either, but he proved it. He showed stuff to prove it. So let's take a look. I'm going to hold this for just a second. So inertia is the resistance of any physical object to any change in its velocity. You saw that in that movie Gravity with Sandra Bullock, remember? When he threw something, it went on forever and ever and ever. It never stops. So some external force has to stop it, be it collision, be it gravity of another object. Something has got to stop it. Otherwise, everything is moving and will continue that motion. So he made something like this. This ball now, you put it up here, and it keeps going up and down, up and down. The less friction between the ball and the surface of this bowl, the longer the ball goes up and down. So if you made something that was really super smooth, the ball kept going back up, back down, back up, back down. This was the proof that he was correct. The law of inertia is a correct law. And in fact, Newton, that is going to be born after Galileo dies, that's his first law of inertia. Object in motion will continue that motion unless it's acted upon by an external force. Right? That law. Then he develops this inclined motion, But he puts balls up here, and these balls roll down this track. And as they roll down this track, he can time them. There's little bells here. When the ball goes through these bells, let me make it a little bigger so you can see a little easier. So he puts the ball up here. The ball rolls down, and he times them. He says, how long does it take something to reach the bottom of the track? It turns out something that was a bowling ball reached the bottom of the track at the same time as a little tiny ball. And this is his law. This is how he did all his experiments. He didn't throw stuff down the Tower of Pisa. That's what he's famous for, but he never did that. This is how he made his experiments work on inclined surfaces. Works just as well as dropping stuff. Right. More drawings. Okay. I'm done for today, you guys. It's only 1:42, but I'm done. Is there any questions you guys would like to ask me? Anything that comes to your mind?
I do.
Somebody said that?
Yeah. I was wondering when you were mentioning about like when Galileo discovered like with the epic center with the epic cycle, and you were saying
Ptolemy.
how,
That wasn't Galileo. That was Ptolemy.
oh, okay.
Yeah.
But was it able, so it was able to find out that the sun was in the center of the universe?
No.
But was it able to find out like Venus's rotation as well, or was it just like?
No, the difference between Ptolemy and Galileo is something like, let's see, about 1,500 years. So they're not contemporaries.
Oh,
So,
okay.
no, he would not know. Yeah.
Okay. Just
No,
wondering.
yeah, see, like what did people do 1,000 years ago? What kind of experiments do you know from 1,000 years ago? Do you know anything that happened 1,000 years ago? Besides
No.
wars and misery and, disease, do you know anything else from 1,000 years ago in Europe? Anything discovered that you might know? Any innovations? Anything that you guys have heard of? Bicycle? Anything 1,000 years ago? Zero, zilch, right?
Yeah, I haven't heard
Nothing
of
happened. There was no science done 1,000 years ago. There was just wars, misery, the Dark Ages. That's what they call the Dark Ages. That's what the Dark Ages are. So after Galileo, right after Galileo, we're talking about Renaissance. This is when Renaissance starts with Copernicus's idea that the sun is the center of the universe. So this is the beginning of Renaissance.